So just a little refresher with section 6.2. In this section, we are multiplying and dividing rational expressions. So far, we only saw multiplying rational expressions, like in example 1. We have here this fraction, this rational expression times this rational expression. Your whole goal in the end is to multiply and simplify, but the easiest way to go about it is actually factor before you multiply, because once you have it factored, then if you have the same thing in the top as you do in the bottom, so you have the same exact thing in the numerator as you do in the denominator, those things can cancel out, which then means that all of these different terms can kind of go away, and you don't have to have a million terms. You might be breaking it all the way down and only have a couple left over instead of having to multiply a 3-term polynomial times another 3-term polynomial, which would take a long time. So that's what we did here in example 1, example 2. I believe we have this problem here, the you try problem, to start on page 6. So if I gave you this problem and I said multiply and simplify, the first thing you would want to do is factor everything that you can factor. So what's confusing about these problems is they're all different, and the way that you factor is always different. So like sometimes you'll be using a GCF method. Sometimes you'll be using factoring trinomials. Sometimes the leading coefficient is 1, so you can just figure out what multiplies to be this and adds to be that, and you can factor it instantly. Sometimes the leading coefficient is not 1, and you have to do the long process and then factor by grouping. So for this problem here that you try, we're going to do this together because I know it's been a few days since we completed these types of problems. What I'm going to do is on the right-hand side, where I just put that line times the other line, those are going to be the factored forms of the polynomials here. So I'm going to take all of the parts that can be factored, and I'm going to factor them separately. The only thing that can't be factored as I'm looking at these 4 different parts of the numerator and denominator of both fractions, the t plus 2 at the bottom cannot be factored. The only thing I could do with that is take out a 1, so that's not helpful. So I know that t plus 2 can just remain t plus 2. Everything else, though, can be factored. So I'm going to have to take the time to factor each part separately, and then I'll put the factored form up there in that in its position. So the first thing that can be factored is 2t squared minus t minus 15. So in order to factor a trinomial that has a leading coefficient that's not 1, we have to figure out the first number and the last number and multiply them. So the a and the c. The first number is 2, the last number is negative 15. So when I multiply a times c, that would be negative 30. We have to find the factors of negative 30 that add to be the middle number, which is negative 1. So when you're finding the factors, if it's still helpful for you, you can take the time and list them all. 1 and 30, 2 and 15, 3 and 10, 5 and 6. And then in order for these to multiply to be a negative 30, the two numbers will have to be like one positive and one negative. So if you're thinking about the factors like 1 times 30, if one was negative, you would either get a 29 or a negative 29 if one is positive, one is negative. So they're too far away from each other. The two factors that you would need would be 5 and 6 since they're 1 away from each other. And if you have one of these positive and one of these negative, in order for them to add to be a negative 1, you would need the 5 to be positive and the 6 to be negative so that they combine together to be the negative 1 that you need. So once you find the lucky factors that do this, you basically need to add the variables to them, like 5t and negative 6t. And you need to take the original problem, which is the 2t, I'm going to rewrite it over here, the 2t squared minus t minus 15, and you're separating the middle term into the two terms that you just found. So you're going to separate a negative 1t into 5t minus 6t. You're doing that because whenever the leading coefficient is not 1, you have to factor by grouping, and you can only factor by grouping if you have 4 terms. Once you have completed that step, then you will draw a line down the center after the second term, and you factor each side using the GCF method. So 2t squared plus 5t, the only thing that I can take out of both of these terms is 1t. And when you're factoring something out, it's the same thing as division. So if I divide out one of the t's from 2t squared, I'm left with 2t on the inside, plus if I divide out the t from 5t, I'm left with 5 here. So this factors out to be t times 2t plus 5. The next one, whenever you have anything in the factoring world, whenever the leading coefficient is a negative, you have to factor out the negative. So something you always have to do, and you just have to memorize that. So I have to factor out a negative since that's a negative 6t. And the largest thing that goes into negative 6t minus 15 is going to be a negative 3. So I take out here a negative 3, and on the inside, I'm putting whatever I would have left. So it's confusing when you take out a negative. Like if I divide out negative 3 from a negative 6t, I would need a positive 2t here, since negative 3 times 2t is negative 6t. And if I take the negative 3 out of a negative 15, I would need a plus 5 here. So once I factored both sides using the GCF, I can see the 2t plus 5 is matching up inside the parentheses for both, which means I can rewrite this as the product of this part, which is t minus 3. You can put that into its own set of parentheses, all times 2t plus 5. So I did all of that work, and all that got me was just the factored form for the very first one. So this is definitely time consuming. So this is going to be t minus 3 times 2t plus 5. I hate using t's, they look so similar to plus signs. And that's the factored form for the numerator. The denominator of that fraction t plus 2 can't be factored, so let me move over to the next numerator, which is t squared minus t minus 6. Thankfully, this one, even though it's a trinomial, it's an easier trinomial to factor because the leading coefficient is 1. So when this does happen, I do want you to realize you can still always take the long way. You can still do this whole process and factor it by grouping, but for this problem, because it's just what multiplies to be negative 6 and adds to be negative 1, you can just factor it automatically. I did see that a lot of students are using the long method each and every time, which is just a little concerning only because I know that applications that give you answers will always use the grouping method, but I've always taught it that if this number here is a 1, then you can automatically just factor it without doing the long method. So I do realize and see that. So if you know that you're not being honest, I pretty much know that as well. I can't prove it because essentially you could do this long method each and every time. But if you're similar to me in that you want to get the right answer, but you don't want to have to do all of that work and use all of that time, I taught you a very quick and easy method that a lot of you I'm seeing aren't using, so it's very interesting to me to see that. So when the number here, this leading coefficient is a 1, I know that I can just factor it automatically into being t plus something times t minus something, because this number is a negative. In order to multiply to be a negative, one has to be positive, one has to be negative. So I just have to pick the right factors that multiply to be negative 6 and add to be a negative 1. The only factors of 6 are 1 and 6 and 2 and 3. Since 1 and 6 are too far away from each other, if one was negative, one was positive, you're either going to get 5 or negative 5, so it's not that pair. It's 2 and 3. And in order to add together to get a negative 1, the 3 would have to be negative since it's the bigger number. So we would need t plus 2 times t minus 3. Notice, I can go from just the original polynomial to factored form without doing anything else, and that's because the leading coefficient is 1. This process over here does always work, but I've always taught you from the very beginning that you can just do this easy process whenever this number here is 1. So this can be t plus, not t squared, t plus 2 times t minus 3. And then the last thing I have to factor is the denominator, t squared minus 6t plus 9. Again, thankfully, the leading coefficient is also 1, so the factoring process should be a little bit easier. I just had to factor it into what multiplies to be positive 9 and at the same time adds to be a negative 6. If you think about that for a second, what multiplies to be a positive but at the same time adds to be negative is confusing because you would think that that's impossible. But whenever you multiply two negative numbers, you're going to get a positive answer as your product, and you'll get a negative answer as your sum. So that means that when I factor this, I'm going to need two t minuses. I'm going to need t minus blank times t minus blank. And the numbers that multiply to be a positive 9 and add to be a negative 6 would be t minus 3 times t minus 3. Now, if this was just like your final answer, a web assign would normally tell you that you would have to write it as t minus 3 to the second power, since it's the same thing twice. But because we're canceling things out, I'm going to write it the long way by just writing two t minus 3's, because I like to physically be able to see things cancel out completely. So once I have everything factored, essentially what you would have to do is multiply everything out and simplify. But before you even have to do that, you're going to want to cancel things out that are the same in the top as they are in the bottom. So the first things that I see are these two t minus 3's right on top of each other. I can cancel those out since it's in factored form and they're the same exact thing. I can also cancel this t minus 3 with this t minus 3 because, again, one of them is in the numerator and one of them is in the denominator. It's okay that they are diagonal. If you were to multiply it out, you could move things so they're directly underneath of each other. It's not needed, but those do cancel out. And there's one more pair of things that cancel out. Yes, the t plus 2 here and here cancel out. I know there's no parentheses around this t plus 2, but it's already completely factored, so it will cancel out with the t plus 2 in the top. So after all of that, this simplifies all the way down to just being 2t plus 5. You could keep it in fraction form by putting it all over 1, or you can just leave it as 2t plus 5. That's the final answer. Notice we didn't really have to multiply much. Once we factored it, we saw all of these things cancel out. We didn't really have to multiply anything. We were just left with whatever was left. And that is what will happen. If we flip this page to the next page, we are now going to do the last section, or the last example in section 6.2, which is dividing polynomials. So what's interesting about dividing is I know that, like, from way back when you learned long division when you were in elementary school, like, it was always something that was not really necessarily considered fun. It was always kind of freaky to do long division. What's nice about division, though, especially when we get to Algebra 2, we don't actually ever divide. Like, you're not ever going to see any division happen. What happens with fractions when you're dividing something, dividing anything is the same exact thing as multiplying by its reciprocal. For example, if I was to take something easy like 20 divided by 5, like, you might already know, like, 20 divided by 5 is just 4, and it is. 20 divided by 5, though, is the same thing. And I can write it in a different way. I can write it like this, too. 20 divided by 5 is the same exact thing as taking 20 and multiplying it by the reciprocal of 5. So if you remember, the reciprocal of 5 is 1 over 5 because you flip the number upside down. 5 technically is a fraction. It's 5 over 1. When you flip it upside down, it turns into 1/5. And if I was to multiply 20 over 1 times 1 over 5, you're going to get 20 times 1 is 20, 1 times 5 is 5, 20 over 5 is still equal to 4. So, like, you get the same exact answer either way, and no division really needed to happen. You just multiply by the reciprocal. So that's what's going to happen with polynomials. Whenever you divide fractions, it's the same exact thing as multiplying it by the reciprocal. So maybe in, like, a pre-algebra class, you might remember your teacher saying keep, change, flip. And that goes along with keeping the first fraction the same. So that means that x over x plus 3 remains the same. But then you change the division sign to be multiplication. And then you flip the second fraction completely upside down into x minus 1 over 4 like that. And once you do that, then you can just follow the same steps we did in the last example, in that you would factor everything that can be factored, and then you would cancel anything out, and then if nothing cancels out, you're just left with whatever is left. In this case, when I go to divide and I keep the first one the same, I changed division to multiplication, and I flipped the second one upside down to be its reciprocal, I don't see anything that can be factored, and I don't also see anything that can be canceled out, because there's nothing the same in the top as there is in the bottom. These x's right here, like that one and that one, cannot cancel out because they're not exactly the same exact thing. The only time things can cancel out is if you literally see x minus 1 on the top somewhere and x minus 1 on the bottom. Because this is a random x and this is x plus 3, I can't cancel out those x's, just like I can't cancel out this x with this x down here. So if I said simplify this, really all you would have to do then is just multiply your numerator times numerator. X times x minus 1 would look like this, x times x minus 1. And then the denominator, x plus 3 times 4, I'm just going to put the 4 in the front, 4 times x plus 3 in the denominator. And depending on the directions, that would be considered the answer, unless they said put your answer in standard polynomial form. This is in factored form. If they said put in standard, then your answer would require you to actually multiply, in this case using the distributive property. X times x is x squared minus x times 1 is x over 4 times x is 4x plus 4 times 3 is 12. This would be in standard form. The other answer would be in factored form. It depends on the directions of the question. If the question if it doesn't specify what form to put it in, leaving it like this is totally fine. If the directions are telling you you must put your final answer in standard form, you would then need to get rid of the parentheses by using the distributive property. So let's see how letter B works. Hopefully when we go to do these problems, we see some cancellations. So in letter B, in order to divide any fractions, the first thing I'm always going to do before I even factor is set it up so that there is no more division. To get rid of the division, you keep the first fraction the complete same way that it comes in the problem. You change the division to be multiplication, and you flip the second fraction upside down. So it's going to be x squared minus 6x plus 8 on the top, and then it's going to be x squared minus 2x on the bottom. Once you've done that process, keep, change, flip, then it's time to do the same thing we did before, which is factor everything that we can, cancel out anything that's the same, and then multiply whatever you're left with. So I need to factor all 4 parts. Looks like the top left-hand corner, 5x, there's nothing I can do there, that's just 5x. But then I can factor the bottom, 3x minus 12, by using just the GCF method. The GCF of 3x minus 12 is 3. So I'll take a factor of 3 out, like dividing a 3. If I divide out 3 from 3x, I'm left with x minus, if I divide 3 out from 12, this would be 3 times x minus 4. Okay, that part is factored. Now moving on to the top right-hand corner, x squared minus 6x plus 8. This one is another one that has a leading coefficient of 1, so I can quickly factor this to what multiplies to be positive 8 and at the same time adds to be a negative. In order for that to happen, I need both of my factors to be negative, since a negative times a negative is a positive, and a negative plus a negative is another negative. And the 2 factors that would do this would be x minus 2 and x minus 4. So I can factor the top to be x minus 2 times x minus 4. And then the bottom, x squared minus 2x. I know sometimes it's hard to determine what method do I use to factor. Sometimes you have 2 terms and you can still factor like a trinomial. If that middle term ends up being 0, it still can be factored that way. Even though we have x squared and we have the middle term, this cannot be factored using the trinomial method, which the answer looks like this, because it's missing the last number here. So it's what multiplies to be 0 and adds to be negative 2. You can't do that. The only way you can factor this one is using the GCF. So you can take an x out of both of these terms, and when you do that, you're left with x minus 2. So down here will be x times x minus 2. Once you have everything factored and you got rid of that division by flipping it upside down and it's ready to go, now it's time for cancellation. So you're looking for the same thing in the top as you see in the bottom, which I see a lot of things that can cancel out, which kind of makes me happy because all of this stuff ends up going away. Like these x minus 2's, like that one and that one go away. This x minus 4, this one and this one goes away. And even this x and this x can cancel out. I know it's 5 times x, but you can basically factor 5 times x into being 5 parenthesis x, and that x will cancel out with the bottom x. So after doing all of that, this ends up just being a nice, easy answer. This ends up just equaling 5/3. So I think we should be ready to try one on our own. So the next problem you see here, first thing you should do is rewrite the problem so that it turns into multiplication. You do that by keeping the first fraction the way that it is, changing division to multiplication, and flipping the second fraction upside down. After you do that, then it's time to factor, cancel out anything that can be canceled, and then whatever you have left would be your final answer. So go ahead and take a few minutes on this you try problem. We'll go over it in a few. All right, let's go over this answer and see how you did. So the first fraction, you're always going to leave the same. So it's going to say 4x over 3x minus 3. The second fraction is going to flip upside down as soon as you change the division to multiplication. So it'll be x squared plus x minus 2 on the top and x squared minus 2x on the bottom. Once you have it set up, then it's time to factor and then replace the factored form for all of the different parts into the fraction over here at the right. 4x cannot really be factored, so I can just leave it as 4x. 3x minus 3, you can take a factor of 3 out, it turns into 3 times x minus 1. And then x squared plus x minus 2. We're trying to figure out what multiplies to be negative 2 and at the same time adds to be positive 1. So I'm going to need the factors x plus a number times x minus a number, since that's the only way you can get a product of a negative is by having one positive, one negative. And in order for this to happen, in order for it to add to be a 1, it would have to be a positive 2 and a negative 1, since the only factors of 2 are 1 in itself. So then this factors to be x plus 2 times x minus 1. And then the denominator x squared minus 2x. The only thing we can do here is factor out an x, and you're left with x minus 2. So once we get to this part, then it's time to cancel out anything that is the exact same in the top as it is in the bottom. So the things that I see that are exactly the same would be this x minus 1 and this x minus 1. Those can go away. I can cancel out this x here with this x here. Those can go away. And that's it. I cannot cancel out the x plus 2 on the top with an x minus 2 on the bottom because it's not exactly the same thing. It needs to be exactly the same. So then what I would do with what's left is actually go ahead and multiply. 4 times x plus 2 is the only two things that are left on the top. And then 3 times x minus 2 is on the bottom. Now, this would be the final answer simplified in factored form. This is the answer to the actual problem. When you divide, that is it. Depending on the situation or the directions, they might tell you to put it into standard form. That would mean, in this case, multiply 4 times x plus 4 times 2 to get 4x plus 8 on the top and 3x minus 6 on the bottom. Both of these are correct. They're equal. One is in factored form. One is in standard form. It depends on the question and how they want you to leave your final answer, whether you would have to just leave it the way that it is in factored form or then multiply it out to put it into standard form. It really depends.